Okay, we're on page 643, exercise 9.4. You have a little handout there. There's a couple of things I didn't put on your handout. If you want to turn back to page 636 and write down what associative means and what commutative means. If you didn't know it already, and if you already know what it means, then I guess you don't need to write it down. And then on page 637, you need to write down what identity means, if you don't already know it. So now let's see if we can work some problems here. In problems 1 through 7, we're using the picture on the board. It's also on the page 643. And what does it say? Find, problem 2, find A, circle A, find A, circle A, B, circle C. And did they have a parentheses around it? Yes, right here. So what do we do first? Do they have a circle? Did I put the wrong thing up in the corner? Sure enough, it's one of these. So, what do I do first? B at, that's not a very good one, is it? B at C, and then I take that answer at A. And this is our operation. I mean, the only operations you're familiar with are what? Add, subtract, multiply, and divide? Well, I just introduced you to another operation called at. And A at A equals what?
C.
And A at B equals?
A.
And A at C equals?
B. Why?
Because that's what they told us.
Okay.
Because that's what happens when you do the operation circle A. So they had to give us some information.
So, if A was 1 and B was 2 and C was 3, then A times A equals C. 1 times 1 equals 3. And this operation?
That would be right, if you put numbers in there.
Not times, but like at.
At, yeah.
That's
A
very
at, whatever
weird.
whatever that operation is, that's what would be going on.
And what's the purpose of this one?
What is this section called? Abstract Mathematical Systems.
Yeah, very well.
Now did you just figure out what's going on? We're doing some abstraction today. So, what's B at A?
A.
What's B at B?
B.
And B at C.
C.
There you go. So, what's B at C?
C.
What?
C.
C. So I put C down here for my answer, and then I go, what's A at C? And what's the answer? A at C is, you're not going to tell me. A at C
is B.
is B. So the answer to this problem is B. Now, what do they want me to do next? A at B at C. Do it again. A A at B at C, except now they want me to group it like this. What's A at B? A at B is
A.
A. What's A at C? B. So we get the same answer both times. So guess what we just discovered? That the operation at is, what property is that? When you can group them, have three of them and group them either way and you get the answer?
The associative property.
Associative property. That's the associative property. Are the results in parts A and B identical? Yes. Which means this operation is associative. Okay, number 4. Find the following. Now what they tell me to find for number 4? A at B at A. A at B at A. And is it the A and the B that's in parentheses? Good. What's A at B? Tell me. A at B is A. And what's A at A?
C.
What?
C.
C. Everybody follow that? Then what are they doing next? ABA. A at B at A, except now they're doing it this way. What's B at A? Sorry. What's B at A?
A.
A. What's A at A?
C.
C. So again, it's associative. Question 6. Is the operation at commutative? What's commutative mean?
No idea.
Is that what commutative means?
Yeah.
Square at triangle equals triangle at square. Is that commutative?
What's commutative?
It's on page 636.
System is a
Yes.
Okay, so now, is this commutative? Well, is A at B the same as B at A? What's A at B?
A.
A. What's B at A?
A.
A.
B
Is A, so we've, oh, so let's just put it right here in between, okay? So we can keep writing some more. So is A at C the same as C at A? What's A at C? B. What's C at A? B. Everybody see what I'm doing? Looking at the chart?
Wait.
C at A is what?
B.
B. So we have, what's B at C? Is that the same as C at
But
B?
why are you doing that with the triangles and squares? I don't understand.
I put a square and a triangle are empty spaces for different numbers.
Are you just putting in different numbers though, or are you doing?
Yeah, I'm just
all-
taking the stuff we have here and going A at B, A at C, and B at C.
Okay.
I'm just working all these. I'm working all the possible problems for this system. Okay. What's B at C?
See.
C. What's C at B? C. And I just put these empty boxes up here, hoping that your mind would think something goes in the box. And I made a box and a triangle so you'd see that we're putting different numbers in there. But technically, we could put A and then reverse them, but you see where it's going to be the same? So the ones I'm checking out are A and B and A and B and C.
Mm-hmm.
So I've done A with B and A with C, and I've done B with A and B with C, and have I done C with B? Yeah, and C with C. See what I'm doing? I'm just checking them all out. So is the operation at commutative?
Yes.
Because we just checked out all the problems? Well, there's another way to do this too. We could draw a diagonal like this. And is this a mirror reflection on both sides?
Yes.
Mm-hmm.
If you draw this diagonal and this side reflects that side, if you can just flip it over, then that means it's
Commutative.
commutative. Where does that come from? Page 637. So you see, you kind of want to keep this chart with your notes on it to bring with you for the test, so you can answer some of these questions.
Could you look at 7, because there aren't any other problems like it.
Which one?
7.
That's really the one.
Is the set S closed? What's set S they're talking about?
I don't know.
Oh, the one we was just working on here on the board. See where it says in problems 1 through 7, consider set S?
Oh.
And this is set S. You see that?
Yeah.
So you're looking at this picture for number 7. And what's question 7 say?
Is the set S closed with respect to the operation A?
Do you know what that means?
No.
Do you have a handout there?
It says the set A is closed under the operation star, which would in this case
Pick up
be
your
at.
handout.
If for all
Celeste,
A,
read what
B,
it says.
And A at B is also an A. But I don't understand what that means practically. It just sounds like a whole bunch of jibber jabber.
Thank you for being candid. Every time we operate on any two of these, do we get A, B, or C?
Yes.
Then
And no other.
that means
It's closed.
it's closed.
Mm.
Because all the answers for all these operations end up being one of these letters, A, B, or C. Now, do you know what that means?
Mm-hmm.
Good. That means, when you all shook your heads yes, that means we're sitting here doing abstract math. Do you feel powerful?
I feel abstract.
That's a good way to put it. I feel abstract. Good. Number 8. Oh, we have to draw another picture. So we can erase this one. And draw another picture. Whoops. I'm going to draw it in black so it'll be easier to see on the video. And what's the operation? F. And what's the set?
1, 2, 3.
2, 3. 1, 2, 3. You got it? So make a table that will define the operation F on the set A. So that means we're going to go 1, F1, 1, F2, 1, F3. Then we're going to go 2, F1, 2, F2, 2, F3. Then we're going to go what? 3F1 and then 3F2 and 3F3. What's 1F1?
1.
3.
What's it say? The operation F means the same means to select the first of two numbers A and B as in example 8, which is on page 639. So select the first of two numbers. So what's the first of the two numbers?
1.
1. So what's 1F2?
2.
What?
Would it be 2?
Select the first of the two numbers.
Oh, 1.
What are the two numbers?
1.
1F3.
1.
2F1.
2.
2F2.
2.
2F3.
2.
3F1.
3.
3F2. 3F3.
There's no.
Are you ready to count to 3 and say abstract math is this stupid? Now let's fill in the chart. What's 1F1?
1.
1F2?
1. 1.
What's 2F1?
2.
2.
2.
2. 2.
3.
3. 3.
There, we filled the chart in.
Looking.
So now we've got the chart filled in. Is A closed under the operation F?
Yes.
Yes.
Because you got one of the elements, 1, 2, or 3.
Yep.
Good. Powerful. Second question. Is the operation F commutative? In other words, does 1F2 equal 2F1?
No.
No. See that? So is it commutative?
No.
No. What's the next question? For any three numbers, show that AF, B, FC equals AF, B, FC, different parentheses. So let's put it up here. No, come over here.
Wait. Is she doing 10? Or is she doing D?
She's doing D.
Oh.
And which one did they do first? AF. This one? and then this one. Is that the way they did it? Why am I putting empty boxes? Because we're going to put numbers in there. So for any three natural numbers, A, B, and C, so what are the numbers we're using?
1, 2, 3.
1, 2, 3. 1, 2, 3. So what's 2F3? What's the answer to 2F3?
2.
What?
2.
2. What's the answer to 1F2? 1. What's the answer to 1F2? 1. What's the answer to 1F3? 1. So let's try 3, 2, and 1. 3, 2, and 1. See what I'm doing? I'm just putting different numbers in here. What's 2F1?
2.
2. What's 3F2? 3. What's 3F2? 3. What's 3F1? 3. You follow what's going on?
Mm-hmm.
So, what do we say about this group? What's that property?
That's the associative property.
Yes, it is. Page 636. Write that on your little paper. That's the associative property. No matter how you associate them. Now, when you're actually teaching mathematics to children, here are the implications for this. 3 plus 4 plus 5 equals 3 plus 4 plus 5. This equals this. Agreed?
Mm-hmm.
What's 3 and 4?
7.
7. And 7 and 5 is 12. What's 4 and 5?
9.
9. And what's 9 and 3? 12. And do you understand that that's going to bother some of the little chippers you're teaching math to? That's why we're having you think about this at this theoretical level, at this abstract reasoning level. Okay? So are we ready for number 10? Let S be the set of multiples, 0, 5, 10, and so on. So now we have 0, 5, 10, what's next? 15, dot, dot, dot. 0, 5, 10, 15, dot, dot, dot. Why is that thing bouncing around? I don't know why. Number 10. Is S closed with respect to multiplication? If I multiply any two of these, well, what's 0 times 0? What's 0 times 5? What's 0 times 10? What's 5 times 0? What's 5 times 5? What's 5 times 10? What's 5 times 15? You understand? If I fill this chart out, will I always get a multiple of 5?
Yeah.
Yes. Is the operation of ordinary multiplication commutative? What does that mean? Does 5 times 10 equal 10 times 5?
Yes.
Yeah.
Does it? Yes. Is the operation of ordinary multiplication associative? What does that mean? Is 5 times 10 times 15 equal 5 times 10 times 15? And we go 5 times 10 times 15 is 5 times 10 times 15. What's 5 times 10? 50. What's 50 times 15? 750. Right? So what's 10 times 15? 150. What's that times 5? 750. So what do we say? Is it associative?
Yep.
Yes. Number 14.
Are you going to do number 12?
No. You want to?
Well,
Let's just,
I
okay,
just
let's
didn't
do
know if it
it.
would help us
Let's
with
go ahead and do
number
it.
11.
Let's go ahead and do it. What's it say, number 12? 0 and 1. So I have 0 and 1. 0 and 1. Give an example of an operation under which 0 and 1 is not closed. Okay, what happens if you add? What do you get? What's 0 and 0?
0.
What's 0 and 1? What's 1 and 0? What's 1
0.
plus 0? What's 1 plus 1?
Oh, plus. Sorry.
2.
Oh, I thought
Is it closed?
No.
Oh.
What do you have to get if it's going to be closed? If this is your set S, if S is your set, 0 and 1, then all of your answers have to be
0.
0 and 1. Give an example of an operation where it's not associative. Associative would be what? 1, 2, 3 equals 1, 2, 3. And you figure out an operation there where you can put 0 and 1 in there. And what are the operations you have to deal with? Add, subtract, multiply, and divide.
That makes sense.
So which one would give you something that doesn't match? Division? Why would I pick division? Because when I divide, what am I going to get? What's 0 divided by 1? There is no number. That's undefined, isn't it? And then give an example where it's not commutative. Commutative would just be switching the order.
Mhm.
So addition you could switch it. Subtraction, you could switch it. Multiplication, you could switch it. Looks like it would be division again. Would be the one that would mess us up, wouldn't it? 1 divided by 0 does not equal 0 divided by 1, does it? What's 0 divided by 1? You divide 0 by any number, and what do you still have?
No, 0.
0. You take nothing and divide it into 2 parts, into 3 parts, into 4 parts, you have 4 parts of nothing. Whereas 1 divided by 0, you can't do that. So you're not getting the same answer. So I would use division as my example. That wouldn't work. Number 14. Now find the following. Well, now we've got a different thing going here, don't we? I might need to move this over a little bit. And what do we have going for number 13 through 18? We got this little symbol here. And then what do we have? Empty set, A, B, and AD. Empty set, A, B, and AB. Empty set, A, B, and AB. Okay? And have they filled the chart in for you? Empty set, empty set, empty set, empty set. Do they have the next row filled in? Empty set. What's next? A. Empty set. A. Everybody see what I'm doing? I'm copying the chart. For B, do they have that one filled in? Empty set. Do you know what to put here?
Empty set.
Empty set. Everybody know why we put empty set there?
But there's not a B.
Because B and A don't have anything in common, do they? Then what's the next one?
B.
B. Everybody see where we're getting this stuff?
No.
Okay, look. What's the intersection? What's the intersection of B with empty set? Go back to the chapter on sets. What's the intersection of the set B with the set empty set? What do those two have in common? Empty set.
Oh.
What does the intersection of set B have with set A?
Nothing.
Well,
Empty.
the one thing, because if you took all the subsets, empty set.
Oh.
Oh. What's the intersection of set B with set B?
B.
B.
Wouldn't it be B and empty set though?
But you're looking for these elements here. So what's the intersection of B with AB?
B.
Everybody see that? So now what's the last one? So have you figured out what goes on this last row?
Empty set. A. B.
Empty set, and then A. Everybody see Y?
Mhm.
And then what? B. Everybody see Y?
Mhm.
And then what?
A and B.
A and B. Well, do you feel powerful? No, I have a headache. Now, let's do, oh, I just did one of your problems. I can't believe that.
Oh no. What
Let's
did
do
I
number 14. Now, find A intersect B. Is that what it says for number 14? Intersect AB with parentheses. Intersect. The set is almost for A and B. So what's the intersection of A and B? Empty set. Where does empty set intersect with the set AB? Empty set, right? Now what do I do next? A, now they want me to come here and go A, B, and AB, don't they? And now they want me to put the parentheses here. What's B intersect AB? Right? Where does A intersect? Where does A intersect B? Empty set. So we got the same answer both times. So what do we conclude about this operation? Are the 14, are the results in parts A and B identical?
Yeah.
Did we get the same final answer?
No, we did not.
Yes.
You did.
So, what do we conclude? That it's probably what? Associative? Now, they give you some problems to work, so I'll just let you work them. Number 18. Is the operation commutative? Is this operation commutative? That is, does now does that make sense? So that's when I'm putting boxes and triangles up here, empty places. So what can we do? We could do all four of them. You follow me? We could make a chart like we did before. Or we can get our little green marker and say, hey, I learned something earlier that says if I draw this diagonal and if this is a mirror image of that, is it? This is that. This is that. These two are these two. This is that. This is that. What do I conclude? Yes, it's commutative. Is that a cool little trick? And can you see why? Because when you're switching the order, you're just going to different sides of the green diagonal line. Okay. Number 20. Now we have to draw another picture. Boy. Do you see how helpful it is to take the time on your paper to draw these pictures? How it's helping your minds kind of wrap around what's going on? And what are we doing for 20 and 21? We've got this operation called S. And then what are the elements of the set? Where'd it go? 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. And what do we have here? 1, 1, 1, 1. Then what's next? 1, 2, 2, 2. And then what's next? 1, 2, 3, 3. And what's last? 1, 2, 3, 4. You follow what we're doing? Question 20. Does A have an identity element? What's the identity element? It's on your little handout. What's the identity element? Oh, no, it isn't. It's on page 637. I'm sorry. What's the identity element?
For each element x in A, x star E equals x equals E.
So something operate with I. They call it E. I'm going to call it I for identity element. Equals that something. You understand that? What's the identity element for multiplication in numbers that you work with all the time? What number can you multiply by any number and it doesn't change the identity of the number?
1.
1. So 1 is the identity element for multiplication. What's the identity element for addition?
0.
Because I add 0 to any number and it doesn't change that number's identity. Now, what's the identity element for this operation? It would be the element 1, 2, 3, or 4 that when you operate with it, it doesn't change the identity. So, are you following me, ladies? Here's the numbers 1, 2, 3, and 4. I operate with one of these numbers and it still stays 1, 2, 3, and 4. So what's the identity element?
1.
4.
4. Okay.
Because any number times 4 equals that number. All right. This is good stuff. I mean, you guys are doing some good, powerful thinking here. (22), they just changed the picture on us. -1, 0, and 1. Do all that work and then they change the picture. -1, 0, and 1. -1, 0, and 1. And the operation of ordinary multiplication. So let's multiply. What's -1 times -1? This is stuff you normally do, right? What's -1 times -1?
1.
1. What's -1 times 0?
0.
What's -1 times 1?
-1.
What's 0 times -1?
0.
What's 0 times 0?
0.
What's 0 times 1?
0.
What's 1 times -1?
-1.
What's 1 times 0?
0.
What's 1 times 1?
1.
There. Complete the table. We just did. 24. Now we got the picture completed, we can answer the questions. For the set S in problem 22, under the operation of multiplication, find the inverse, if possible, for 1, -1, and 0. 1, -1, and 0. And I want the inverse. What's the inverse? 1, times the inverse. Now let's call that 1 times the inverse equals the identity element. You follow that?
Dr. Bonine, I have to leave at 9 again.
Okay.
Just telling you.
1 times the inverse equals the identity element.
Okay.
What's the identity element for multiplication? Of all these numbers, which one doesn't change?
0.
Which one leaves this row the same?
1.
1.
Thank you.
So the identity element is 1. So 1 times the inverse equals 1. What do I take times 1 to get 1? What do I take times 1 to get the answer of 1?
1.
1. So what's the inverse for 1?
Negative
1.
Oh, 1.
What do I take times negative 1 to get an answer of 1?
1.
What do I take times negative 1 to get an answer of 1? Here's negative 1. Here are the answers. How do I get this answer?
Negative 1.
Negative 1.
So the inverse of negative 1 is negative 1. What do I take times 0 to get 1, the identity element? What do I take times 0 to get 1?
There is no answer.
0, 0, 0. There is no 1 for an answer, is there?
Mm-hmm.
So the inverse for 1 is 1, the inverse for negative 1 is 1, the inverse for 0 is none. There is no inverse for 0. Okay?
Mm-hmm.
26. Now they changed the table on us. 0, 1, 2, 3. And at. And 26 says, is it closed? Oh, they give all the answers, don't they? What are the answers for 0? 0, 1, 2, 3. What about for 1? 1, 2, 3, 0. What about for 2? 2, 3, 0, 1. What about for 3? 3, 0, 1, 2. Everybody follow me? See what I'm doing? Filling in the chart, making a picture of it. Because when I'm writing this on my paper, when I'm writing it on the board, my head's wrapping itself around this set that I'm working with. So number 26. Is S closed under this operation?
Yes.
Is the set, S is the set whose elements are 0, 1, 2, 3. Is S closed under the operation of at? Now, what did we just ask? When you do this operation with these 4 elements, do you get one of those 4 elements every time? So, yes. Yes, it's closed. Okay? 28. Find the inverse of 0, 1, 2, and 3. Now I want the inverse of 0, 1, 2, and 3 for the operation at. Well, before I can find the inverse, I have to have the number at the inverse equals the identity element. You follow me? The number at the inverse equals identity element. You follow what I just wrote up here? When I operate on this number, I have to have a number that I can operate on it where the answer is the identity element. So now I have to find the identity element. So is there an identity element? Here's the numbers, 0, 1, 2, 3. Are there any operations where it stays 0, 1, 2, 3?
0.
All these numbers at 0 stay what? 0, 1, 2, 3. So my identity element is 0. Now, watch what we're going to do here. 0 at what equals 0? 1 at what equals 0? 2 at what equals 0? And 3 at what? See what I'm doing? I'm making up problems here. And this little triangle is going to be the inverse. 0 at what equals 0? 0 at what equals 0? What do I do at 0 to get 0 for an answer?
0.
0. So it's 0. 1 at what equals 0? 1 at what number equals, gets an answer of 0?
3.
3. 2 at what
2.
equals 0? 2 at what number equals 0? 2 at what number equals 0?
2.
2. 3 at what number?
1.
At what number equals 0? 1. Everybody follow what's going on? I just found the inverse. For 0, it's 0. For 1, it's 3. For 2, it's 2. And for 3, it's 1. We're going, yeah, I'm starting to register this stuff. Okay. In problems 29 to 32, let f be defined as in problem 8, and let A, L, B mean select the larger number. What is F, as in 29, as in problem 8? What does F stand for? Pick the first number. What does L stand for? Select the larger of the two numbers. And if A equals B, then the larger of two numbers will be the first number.
Okay.
Everybody follow that?
Mm-hmm.
Okay, so number 30. What's in parentheses 4F5? Here's parentheses 4F5. So what's the answer?
4.
30. 4L, 4F5. 4L. So the first number is 4. Now, what's 4L for?
4.
4. So there's your answer to the question. So 30B, 5L, 6F7. 5L, 6F7. What's 6F7?
6.
And what's 5L? 5
6.
larger, 6. Pick the larger one.
6.
6. Everybody follow what's going on? Good. Number
I have to go for a
Oh.
Senate meeting.
Okay.
What problem do you want us to stop at?
Stop when you get to 49.
Okay. Thank you.
You are welcome. So now let's jump over here to 38. The odd integers in problems 38 to 49 determine whether the given set forms a group. On your little handout there, what's the definition of a group?
It's a mathematical system consisting of a set S and operation.
What are the conditions for it to be a group?
Has to be,
Has to have closure. You know what that means, don't you?
yeah, associative identity.
Has to have an associative, has to have an identity, has to have an identity element, and it has to have inverse operations. You have to have an inverse for every element. You follow what they just said to make it a group? So number 40, the even integers under addition. So if we were to do this and say addition, and that would be 0, 2, 4, 6, 8, dot, dot, dot. And what is it asking for number 38? Oh no.
That was the odd integer. You
Odd
went to
integers.
40.
I just did the even ones. We want the odd integers. That would be what?
1.
1, 3, 5, 7, 9, dot, dot, dot. Okay? So, if you add those, do you always get an odd integer?
No.
Where?
Because 3 plus 3 is 6.
7 and 7 is
And
going to
1
be
plus 1 is 2.
14. That's an even one. So, what do you say for 38?
No.
Nope, it's not a group. In other words, you're looking at these conditions and saying, hey, I'll check for closure first, and then if it's closed, then I start checking for the other characteristics that qualify it to be a group. Number 40, the even integers. So now I just changed it to 0, 2, 4, 6, 0, 2, 4, 6, and addition. Does it have closure? Yes, it does, doesn't it? I mean, you add two even integers, you're always going to get an even integer. What's the next thing it wants to know? Is it associative? Does 2 plus 4 plus 5 equal 2 plus 6 equal 2 plus 4 plus 6?
Yeah.
Does that equal that?
Yeah.
Every time?
Mhm.
Yeah. So what's the next property? Identity. Is there something? Does 4 plus something equal 4?
0.
Yeah, 0. See, Daniel. 0 plus all of those is going to equal all of those. So I've got closure, I've got associative. Yes. I've got an identity element. Yes. What else am I looking for? Whoa, we're almost there, aren't we? Inverse. So, does 4 plus something equal 0? Isn't that what inverse means? You operate on a number and get the identity element for the answer. 4 plus what equals 0?
0. Oh, 4 plus negative 4.
Negative 4. Whoops. Inverse. No. You follow what happened?
Yeah.
We just ran down the process checking it out and said, nope. So that's what you do and stop when you get to 49.
I have to get to work, but I still haven't finished my test.
Okay,
I'll come in early on Thursday.
that'll work.
Does that work? And I'll
Sure.
also turn in my homework
All right, that'll work.
because I need to look over it. Thank you.
You are welcome.